So we've got a video for Physics 20, and we are going to look at what a cycle is. And we're dealing specifically with a cycle in terms of circular motion. Once we get into periodic motion, we'll define it. We'll look at it slightly differently. It still works out to be the same thing. So one cycle is one complete revolution in circular motion. So you can see here in this diagram, we have a point here, and that point, as that point moves, it's shifted from here down to here, and then it shifts to here, and then to here, and so on, until it comes back to the same location. And when that happens, it's made one cycle. And sometimes that can be referred to as one revolution. So if we were to have a stone or rock in a tire, and then the tire turns and that rock ends up back in the same position P, we have one cycle. And it's important to understand what one cycle is before we go on to talk about a period and frequency. And so we need to be able to answer or to understand understand period and frequency before we can really talk about circular motion. So period is the time required for one to complete one cycle. So period can be, if you're given time for a number of cycles, you can calculate it by dividing them out. So for example, if I mark a wheel and I spin it and I count 1, 2, 3, and it makes, say, for example, 10 revolutions in 20 seconds, I would have my 20 seconds on top, and there would be 10 revolutions, and so I would have a time of 2 seconds for each revolution. So it's the time for one revolution. The other, and it would be correctly units per cycle, but generally for period we would just say in seconds, because period is always described as time for one cycle. Okay. Frequency, on the other hand, is the number of cycles that can occur in 1 second. So there's a typo there, sorry. So frequency is the number of cycles in a given period of time. So in the same situation, a wheel has spun around 10 revolutions and it took 20 seconds. So we have 10 revolutions and it took 20 seconds. That gives us a frequency of 0.5 cycles or revolutions per second, and that's more correctly referred to as a hertz. So a hertz is the number of cycles per 1 second. Okay. Now, for those of you who are a bit more old school, you might be used to, or you are engaged with cars, revolutions per minute, RPM. That's not uncommon, and so that RPM is a measure of frequency, and that's revolutions per minute. And that's another way we talk about it. And yeah. So we've got period and frequency. There you can see how those are interchangeable. The period is equal to 1 over the frequency, and frequency is equal to 1 over the period. They're just inverses of each other. So let's do a sample, or an example. So this is example 7.1 out of the textbook. What is the frequency of an automobile engine in which the pistons oscillate with a period of 0.0625 seconds. So a period, so we're told that it's a period. That says that t is equal to 0.0625 seconds, and because it's a period, we know that there's one cycle there. We want to know the frequency. Well, the frequency is the number of cycles in the time, so we have one cycle in 0.0625 seconds, and when we calculate 1 divided by 0.0625, we get 16 hertz. and that's 16 cycles in 1 second. So we have a frequency So the frequency of the piston is 16 hertz. Let's do another example. This is example number 5. We have a hard drive, and it says in the figure, there's a picture of a hard drive there. It stores data on a thin magnetic platter that spins at high speed. The platter makes one complete revolution in 0.00833 seconds. We want the frequency and the RPM. So again, we're told it makes one complete revolution. So we have one revolution or cycle in 0.00833 seconds. So we would call it a period of 0.0833 seconds. Again, to get our frequency, we want to put the number of cycles, which is 1. We have one revolution or cycle, and it takes 0.00833 seconds. We divide that out, and we get 120 revolutions per second, which is 120 hertz. Now, we want to take that frequency and convert its units. So instead of in hertz, we want it in RPM. So we're going to say we want, we know that we have 120 cycles or revolutions in 1 second. And when we're finished, we want to have our revolutions in 1 minute. So we know that we want to get rid of the seconds and have minutes there. So we need to have some unit with seconds on the top and minutes on the bottom. So we know that there are 60 seconds in 1 minute. And so we multiply that out, and we get, I forgot to calculate this one ahead of time, sorry. 7,200 revolutions per second, or per minute, sorry. So that's 7,200 RPM. So it's important to, these are really basic concepts, and it's common for students to struggle with period and frequency because they're so similar. One is the number of cycles per second, that's frequency, and period is the time for one cycle. So here's some practice questions, both out of the textbook and the workbook.